Trig. Trigonometry. And today we're going to focus on just one trig, and that's called tangent. In 2 days, we're going to learn something called sine. We'll learn something called cosine. But today we're only focusing on one, and that's tangent. Now, a trigonometric ratio is just a ratio of lengths of two sides of a right triangle when we compare it to a specific angle. So before we get started, we have to talk about key terms of a right triangle, primarily opposite, adjacent, and hypotenuse. We should already know which line is the hypotenuse. It's the one across from that 90 degrees. It's that longest side, so that's not that bad. That one's fixed. We always know what our hypotenuse is. The other two are subjective on what angle you're talking about. So they're called your opposite and your adjacent. Your opposite is the one opposite the angle you're talking about. So you have to look at what angle you're talking about, and then the opposite one is the one straight across from it. Adjacent is the one that's next to the angle. It's the one that forms the angle. So I think that's the easiest way to think of adjacent. It is the one that forms the angle. So if we look here, this is the Greek letter theta. Theta oftentimes holds the place of just an angle. We always use Greek. A lot of times we use Greek letters to hold the place of an angle. We're not going to do it too much. Most of the time we're just going to say angle A, B, or C. But no, this is just saying, well, this is the angle I'm talking about. Well, if this is the angle I'm talking about, opposite's going to be the one directly across from it. So that's going to be the side I'm talking about. Adjacent is the one, see how it forms the angle with the hypotenuse? Your adjacent is the one that forms the angle. So opposite has nothing to do with the angle. It's all the way across here. Where adjacent is the one that forms the angle we're talking about. And like I said, opposite and adjacent are subjective to what angle you're talking about. So if we look over here, I use beta to say I'm talking about this angle. Well, if I'm talking about this angle right here and I draw a straight line across, this is going to be my opposite side this time. I'm talking about a different side. So this right here would be my opposite side. Note, it doesn't touch the angle. So that means this must be my adjacent side. So once again, if you go straight across, that's your opposite. If you were drawing a line to this, you'd have to draw like a little curly line to get to your adjacent. It's the one touching the angle. So this would be your adjacent side. The cool thing is we always know what our hypotenuse is. Now, with trig, we're only dealing with two of the angles. It's either going to be this one or this one. We're never going to talk about the 90-degree one. We'll never use that one. We're never going to use that one because there's no real opposite adjacent. That means you'd have a hypotenuse, which would be your opposite. So when we're talking trig, we're always talking about these two angles here, the two that we don't know the measures of, or the ones that aren't 90 degrees. So we'll never deal with that 90 degrees. That one's just fixed. We're going to worry about the other two to worry about our tangent, or our sine, or our cosine, which we'll get to in a minute. All right, so the very first one, trig thing we're going to talk about is tangent. Tangent is most often abbreviated with just TAN. You can call it just tan. All right, tangent is a ratio. So if we look here, we have tangent of an angle. That just stands for an angle. So that could be 30 degrees, 20 degrees, 21 degrees, 40 degrees, 45 degrees. So this could be a 45, 45, 90 triangle, and I can still use trig on it. So this is saying tangent of an angle is going to equal the opposite side over the adjacent side. So once again, tangent of an angle. Did I say tangent times an angle? Is there a multiplication between here? No, don't use it as a multiplication. You're going to. About 90% of you are going to. You're going to think you can divide both sides by tangent. You can't, because this is a whole operation. It's like taking the square root of something. You never say square root times 4, right? Doesn't that sound really weird? But some of you are going to say tangent times an angle. It's tangent of. That word is really important. It's an operation. Just like square root of, we don't say square root times 4, we say square root of 4. If you can keep this down, it's an operation that can help you solving equations in the future. So we have tangent of an angle equals opposite over adjacent. So an example, if we would take the tangent of 30 degrees, that's going to equal the side opposite it. So if you look at your 30 degrees and you draw a straight line opposite it, that's 5. Opposite would be 5. It'd be my straight line from that angle A all the way down there. So that would equal length 5 over, and my adjacent side, remember, we're not using the hypotenuse, we're using the adjacent side. So that would be that 5 square root of 3. And that's what they equal. They're a ratio between each other. When you have a calculator in your hand, you can actually do the tangent of 30 degrees, and it's going to equal 5 over 5 square root of 3. In fact, let's go ahead and do that real quick. Let's take out our calculators. We're going to do a little bit more, but it's good to do it now. Now, the big thing is you need to find your tangent button. If you have a scientific calculator, you're going to have a dedicated tangent button that says TAN. Can everyone find that TAN button? If you can, I'll walk around. All right, what I want you to do is hit that TAN button, and usually it has like a parenthesis. It's saying, well, input something. So that's when you're going to type your 30 in. I want to make sure I'm not. All right, and then go ahead and hit enter. You should get out 0.57735. If you did not, it just means your calculator is in the wrong mode. You have radian mode, degree, minute, second, and degree mode. Whose calculator did not spit out 0.577? All right. Quick one is, can I see your calculator real quick? If you have something that's a Texas Instrument, one of these big ones like this, one of the big ones that are graphing, what I want you to do is, there's a mode button right in your top left. There's a second button right next to it is a mode button. Cozy might be the only. Does anyone else have one of these? Okay, Cozy. So we'll do this. So you're going to hit this mode button. And if you look down about 3 rows, do you see how it says radian? Oh, the radian. You're just going to go, you're going to key over, and you're going to go ahead and hit enter. And you'll see that it's just solid on degrees, right? And then you can either hit your clear button, or you can just hit second, quit, and that will bring you back to your home screen. And then there you go. All right. You did, right? So on these, yeah, so TI-30X. I forget where these are. What was that? Oh, yeah. Yeah, you found it quicker than I could. You had it. So you're gonna, if you look by your second button, there's a DRG button maybe. Yeah. Hit that button. And you'll see it comes up degree, radian, grad form. So just go ahead and hit left and hit enter. And then you should be in degree mode. And once you're in degree mode, don't change it. Okay, yeah.
Is it just degree and there's no like
Oh, you hit second. We don't want scientific or no. Right. That's just going to tell it what mode. So you might have it displayed in 10 to the 30th power or something like that. Those are either you're going to have displayed in decimals or in powers. Right. Don't mess with that. Okay. Does everyone get 0.577 out now? Okay. Awesome. That's big. I promise you. There's going to be test questions that just say plug this. Look right here. This is plug in your calculator. All right, so we all came up with, what, 0.577-ish? Now do 5 divided by 5 square root of 3. What was that? Can I simplify that at all? Yeah. It could be just radical 3 over 3, yes. But we can type it in as just 5 divided by 5. But be careful with your parentheses. Because if you just do 5 divided by 5 square root of 3, your calculator... So think about this. This is a good time to start thinking about calculators. If I typed in 5 divided by 5 square root of 3. Your calculator is going to work left to right. It's going to do 5 divided by 5, and then it's going to multiply by square root of 3. So this is a good time to find your parenthesis button and actually hit 5 divided by parenthesis, 5 times square root of 3, and parenthesis. What'd you get up? 0.57. It's the exact same thing. It's weird how we have an equal sign and it actually equals the other thing. Here's the good thing about this. We can now find missing sides. We're going to do that in a little bit, but you can find missing sides and missing angles using this formula. So say I was missing that 30 degrees. I can just go, okay, tangent of x equals this, and we're going to talk about how to get the tangent to the other side. All right, so this will be good for coming up with solving stuff. All right, let's do this one more time. All right, tangent of 60 degrees. What would tangent of 60 degrees equal in terms of sides? Yeah.
5 radical 3 over 5.
It'd be 5 radical 3 over 5. Because once again, it's opposite. So you look at your 60 degrees, the opposite would be 5 radical 3. Your adjacent would be 5. All right, this one doesn't really have angles. So let's first, what's the length of AB? If I have 12 and 13, what's the length? Yeah, it'd be 5. It's a Pythagorean triple. So we need that. So what it's going to look like if I don't have numbers or something there? I might do something like tangent of C. That's going to apply, tangent of angle C. And what would the tangent of angle C equal? Cozy? It'd be 5 over 12, yeah. No, we're not using the hypotenuse at all. It's just opposite over adjacent. So you go straight across, and adjacent is 12. What would the tangent of AB? Yeah. Maybe 12 over 5. Just for funsies, what would the tangent of B equal? Max? You can't. You can't do the tangent of 90 degrees. In fact, you'll find the tangent of 90 degrees is actually undefined. Most of your calculators plug in tangent of 90 degrees. It doesn't exist. And think about it. It would be opposite over, which one would be your adjacent? And this is your hypotenuse. It's not an opposite. So you can't. Just no. Oh no, we can't do that. Just like over here, we can't do the tangent of 90 degrees over there. So don't use the tangent of that 90 degree angle. You can't do it. Yes?
For the first example, why did you put over 30?
I'm sorry, that should be over 5, right? This one should be over 5, right? I think I said it. Do I have this one over 5? Just me being an idiot. All right, so that should be over 5. Thank you for pointing that out. 5 squared root of 3 over 5, which would just equal square root of 3. All right, using your calculator, we're supposed to plug in the tangent of 74 degrees. We're supposed to make sure it's in degree mode. Let's round to the nearest hundredth. Nearest hundredth. What is the tangent of 74 degrees to the nearest hundredth? All right.
I got 3.49.
You got 3.49. That's what I got. It's either we're both right or we're both wrong. Can I have someone second that?
Yeah.
Cool. All right, what's the tangent of 20 degrees? What is the tangent of 20 degrees? Huh. Whoa, too fast. 0.37? Ooh, we're somewhere between 3.7 and 3.6. 3.6? Okay. So I'm guessing that number out here is less than 5? It's 3, so there. Then we go back to the 0.36. Are we all good on calculators? Don't get these wrong on the test, guys. If I ask you just to plug something in a calculator, get it right. That should be the one you get wrong. All right, look at our next one. It says solve for x. So we have a missing side, but I have an angle. I actually have two angles. And we're actually going to use both angles to solve it and get the same answer. So whenever we have a missing side or angle, we're going to use tangent today. So I'm going to go, okay, tangent. And it says use 50 degrees. So I'm going to say tangent of 50 degrees. Well, tangent of 50 degrees is going to equal opposite, which is x. I don't know the length, so it's unknown. So we're going to have x over 27. How do I get x by itself? I want x equals something. I don't want it to be x over 27. How do I get rid of that 27? Cool.
You multiply both sides by 27.
I'm going to multiply both sides by 27. So multiply that side by 27 to get rid of that 27. We have 27 over here. So what we're going to have is x equals 27 times the tangent. Oh, that's just a t. Tangent of 50 degrees. Now, I don't know about you, but I don't know the tangent of 50 degrees off the top of my head. So that's where we're going to use our calculator. We're going to go, okay, 27 times the tangent of 50 degrees, and I want it to the nearest tenth. So we're going to say x is about something. Yeah.
1.2.
1.2. Is that what everyone got?
Yeah.
I got something different, I think.
Did you guys do 32?
I got 32.2.
I got 34.12. I got 30.
You need to add
40 multiplied by 27.
Oh, yeah.
What was that?
Or 40 multiplied by 27, you get
So
1.
10.
Then multiplied by 27.
Oh, you got to hit enter again. You got to hit enter one more time. Oh, because yours shouldn't have to hit enter twice. Oh, now multiply by 27.
27 times 10.
Oh, yeah.
There we go. Okay. So if you got 1.2 out, you just forgot to multiply by the 27. So what you need to do is, especially those like just scientific calculators, you have to hit 27 times tangent of 50, enter, and it might show 1 point something. Now hit enter again, and then it'll actually do the multiplication. So what's happening is it's doing the tangent of 50 first, hit enter again, and then you'll get your full value. So this should be about 32.2. Is that correct? Okay. All right, we're supposed to do the same thing, but we're supposed to use the 40-degree angle. So we're going to go, okay, tangent of 40 degrees. Can someone tell me what tangent of 40 degrees is going to equal? Lucy?
27 over x.
It'd be 27 over x. Now, here's a cool one that, if you know how to do it, there's a nice little shortcut to it. But we need to get x by itself. So to get x by itself, it seems counterintuitive, but we need to get rid of the fraction first. So I need to multiply both sides by x. You can't multiply by 1 over 20. Well, you can, but then you get 1 over x, and it becomes a little bit more difficult. So what I'm going to do is I'm going to multiply x on both sides.
Can't you just get the reciprocal?
No, because I would lose x from each.
You have to do the reciprocal of both sides.
Yeah.
Yeah, which is basically what we're doing.
Oh, I thought that was.
It'll work. But so we do this, so my x's cancel out. I have x over here. So now I have x times tangent of 40 degrees equals 27. So now what I want to do is I want to get this tangent of 40 to the other side. Well, note, I'm just remember, tangent of 40 is just a number. If you plug tangent of 40 in your calculator, it's just a number. So this is just a number, so you can divide both sides by it. So we can go, okay, let's divide both sides by tangent of 40. You have to divide by the entire tangent of 40 degrees. You can't divide by 40. And we're just going to get x equals 27 over the tangent of 40 degrees. And what is 27 divided by the tangent of 40 degrees? Yeah.
32.2.
32.2. Crazy, huh? It's the exact same thing. You should get out the exact same thing. Just so you know, there's a nice little shortcut. If you have something equaling a fraction, you can always change out the denominator with this. That works for the cross multiplication and stuff. So notice our tangent of 40 just switched place with our x. It's a nice little shortcut on this. All right, so what I'm pointing out here is if you don't want to do this, a lot of times you can just pick the right thing to get your x on the numerator to help just multiply. So sometimes you can pick a better one than the other. All right, so that at heart is tangent. The next thing we're going to talk about is tan inverse. So the inverse of a tangent ratio. Now, remember what an inverse is. Inverse is something that undoes what was just done to it. So if I have 3 times x, and I multiply it by 1/3, I get x back out. So an inverse undoes what the regular thing does. All right? We're used to find the degree measures of an angle given 2 sides. So notice I use tangent to find a side. We're going to use tan inverse to find an angle. So the tangent function tan takes an angle and gives the ratio opposite over adjacent. In other words, tangent of an angle equals opposite over adjacent. And you plug in the information that you have. The inverse, however, is going to take those sides and spit out an angle. So what's going to happen is these two things are going to switch places. So our tan inverse is going to look like this. Tan inverse of the opposite over adjacent is going to equal the angle. So we're going to use the tangent function anytime a side is missing. So anyway, shortcut it. If you know an angle, you're going to use the tangent function. If you're missing the angle, like you have no angles on there, you just have the 90 degree, you're going to use the tan inverse to find that angle. All right, this is where your angle is known. This is when your angle is unknown. And I don't mean you're going to use this every single time. If I say something's 90 degrees and we have an angle that's 30, you're just going to say the other angle is 60. You're just going to do that math that equals 180. I'm talking about if both are missing. If there's just a 90 degree angle and both are missing, we're going to use the inverse to find it. So if we look right here. So an angle plugged into tangent gets you opposite over adjacent. When you take that opposite adjacent and plug it into tan inverse, you get the angle back out. In other words, if we look at this one, just as a quick example, we could say that the tangent of 35 degrees equals 2.8 over 4.0. Well, if I'm talking tan inverse, it'd be the tan inverse of 2.8 over 4.0 is going to equal 35 degrees. So your tan inverse is always going to spit out a degree measure. It's never going to be used to find a side. It's always there to spit out a degree measure. So when you're doing these problems, just ask yourself, am I looking for a missing side? Yes, use tangent. Are you looking for an angle? Yes, use tan inverse. So if we look at this example down here, we're supposed to find the measure of angle B and A. First of all, I'm not asking you to do this. Is there a way to find AB without using tangent or anything special? Yeah. What would you use?
A squared, B squared.
A squared plus B squared equals C squared. Always use that if you need to find a missing side. All right? A lot of times if you have that, you can just use that unless I tell you to use tangent. All right. So on this case, we're supposed to find the measure of angle B and A to the nearest 10. So note, what I'm going to note is if I just use regular tangent, say I'm going to do tangent of angle A. Well, tangent of angle A is going to equal 6 over 20. Well, that's not going to be useful because you can't type in tangent A equals 6 over 20 in your calculator. So note, I'm missing an angle. So missing an angle tells you to use the inverse. So rather than using tangent, I'm going to go, okay, let's rewrite this. Let's rewrite this as tan inverse of 6 over 20 equals angle A. Every one of your calculators has a tan inverse button on it. And most of the time, it's pretty much the same button as your tangent button. You just usually have to hit like the second button on the top left. and you'll be able to use that tan inverse button. Can everyone find that tan inverse button? All right, can we go ahead and hit that tan inverse button and do 6 divided by 20 and see what that results in? Wait. 60.7. Can I get a second on that?
Yeah.
What was that? Oh, did I say 60?
Yeah.
But you said 16. Okay. All right, so we're going to have angle A is about 16.7. And note, anytime you're using the inverse, your answer is going to be a degree. Angle A is about 16.7 degrees. Now, real quick, angles of a triangle equal what?
180.
180. What should be equal then? Yeah.
73.63.
73.3.
Yeah.
Sorry, he stole your thunder, didn't he?
Well, no, wait. No, I think I was gonna answer.
Okay. So we already know what it should be, right? So if I gave you this problem, we would just go get this. But since it's our notes, let's find it again. Let's use tangent to find it again. Noting that if I use regular tangent, tangent of angle B would equal 20 over 6. I can't use that, so we're going to use the inverse to find the missing angle. So tan inverse of 20 over 6 would equal my angle B. Using our calculators, what does angle B equal about? Tali? 73.3. Yep. It's never a bad idea if you have time on a test to just find both angles in case you made a mistake on the first one. Because if this would come out to like 64, you'd be like, wait, one of those is wrong. And maybe you made a mistake on this one, maybe you made a mistake on that one. So it's never a bad idea if you have time to check both angles that they come out. Well, 73.3 plus 16.7, that equals 90 degrees. We're good. Found both our angles. So once again, tangent, use it to find a missing side. Use tan inverse to find that missing angle. It points out exactly what it wants you to do. All right, so we have find the missing variable. I'm just going to go through real quick. Number 1, should I use tangent or tan inverse? Number 2, should I use tangent or tan inverse? Ooh. Which one should I use on number 2, tangent or tan inverse? Tangent. Yeah, we're missing a. Number 3, should I use tangent or tan inverse? Tan inverse because I'm missing an angle. So number 1, we should set up something that looks like tangent of 55 degrees would equal opposite, which would be 38, over B. So we would have basically, okay, multiply both sides by B. Now remember, I said a nice shortcut with this one is you can always just flip these two. This will change place with this one. But you can also do all the math. Multiply both sides by B, find the reciprocal of both of them, doing it that way. I'll just do the work. Multiply both sides by B. We'd have B times tangent of 55 degrees would equal 38. Divide both sides by tangent would come up with B equals 38 divided by the tangent of 55 degrees. Tate, I think I see your hand up. What is that about to the nearest tenth?
26.6.
26.6?
1.
26.1?
6.1.
26.6. All right, round to the nearest tenth. Yeah. Can I have a second on that?
Yeah.
Yep. Okay, cool. I'm going to skip number 2. Let's go to number 3. So number 3, everyone told me to use tan inverse, right? So can someone tell me, I have tan inverse down there. What should I write next? I just have regular old tan inverse. I don't know what goes in there. I'm doing tan inverse of what?
3 radical 15 over 11.
3 radical 15 over 11. Awesome. And that's going to equal
Angle X.
angle x. Perfect. So that means this was nice because this is just strictly just plug in your calculator. Plug in tan inverse of 3 square root of 15 divided by 11. I'm going to let everyone have a chance to plug that in. I'm just going to let everyone have a chance to plug it in. All right, x is about what? Leah? 74.1 degrees?
Yeah.
Yep, we want degrees on it. Can anyone second that? No, okay. No one has this? You have it?
It could be an order of operations.
Yeah, same.
I got 46 point. I got
46.5.
46.6 degrees.
Oh, yeah.
Yeah,
What are we doing?
So it might have just been. Make sure you close your parentheses. Put everything in parentheses that need to be in parentheses. All right. Real quick, number 2 should come out to being. I'm not going to do it because it's the same as the first one ish. 51.9. So check to make sure you can do that. Otherwise, ask questions. Yeah. Still didn't work out? It did or didn't? Okay. Otherwise, the rest of the time is yours to work. I'm going to hand out your test in just a second. Remember, the tests are coming back to me. Okay. Close parentheses. There we go. I think we just didn't close it around the square root.